In this video, we are going to take a look at an application of spherical coordinates to integrating over the so-called ice cream solid. So ice cream solid has a cone on the bottom, okay, and then a hemisphere on the top. So it's like a scoop of ice cream on top of a cone. So here I drew a picture, okay, of this cone using CalPlot 3D. So I'm not doing it by myself, but the bottom is the cone and the top is the hemisphere. So let's see if we can set up the limits. So how do we do that? Okay, so let me try to draw it for you. First, we fix the angle. And just imagine that you are somewhere over here. Okay, so how is your distance from the origin? It's funny how it doesn't draw all the way to 0, but that's just because of the approximation. So anyway, your roar would go from over here, from 0 all the way to this point on the hemisphere. But the hemisphere had radius of 2. So your roar would go from 0 to 2. Now the phi is the angle with the z-axis. So what this is, let me use a different color. So this is, you start over here and then you go all the way up until here. That's the angle phi, right? So this is angle phi. So it'll change from 0 on the z-axis because it's the angle with the z-axis. So it's 0 over here to where the cone ends. So we actually have to figure out what is the equation of that cone. Usually it'll be something like phi equals either pi over 3 or pi over 4, pi over 6. You just have to figure out what it is. So it may be pi over 6, maybe pi over 3, and so on. So we'll discuss that in a second. That's going to be your phi. And then the theta is responsible for rotating around. So theta here is just going to go from 0 to 2 pi. Okay, so let's see if we can set this up. So for theta, it'll be 0 to 2 pi. Now, why did it not like me? Okay, for phi, it'll be 0 to pi over something. We'll figure that out in a second. And then for rho, it's 0 to the radius of this thing, and which is 2, right? Because it's 4 minus x squared minus y squared equals z squared, which means x squared plus y squared equals 4. So the radius is 2. Okay, but as far as this cone, so look at the equation of it. It's z equals square root of 3. And then we got x squared plus y squared. Now here I have the definition of the coordinates, right? So z equals rho cosine phi. And on the other side, you're going to get 3 times x squared plus y squared. But what happens when you square x squared plus y squared? So let me just do this on the side. You will see that you're going to get rho squared sine squared phi cosine squared theta plus rho squared sine squared phi sine squared theta. So you can see that something can be factored out, namely this right here, they share. And then in parentheses, you're just going to get cosine squared theta plus sine squared theta, but that's just 1. So this whole thing is just 1. So that means this x squared plus y squared is rho squared sine squared phi. Okay, now, so we're making them equal each other. So let's go ahead and take a look at what happens. So we get rho cosine phi equals square root of 3, right? Because we're taking the square root. Rho sine phi. Okay, so rho and rho cancels, and then you can divide by cosine phi both sides. So you'll get tangent phi, right? Because sine over cosine is tangent. And then divide by square root of 3. So that'll be equal to 1 over square root of 3. So maybe you remember that tangent of pi over 6 equals 1 over square root of 3. So just to demonstrate, if you want to compute tangent of pi over 6, it's pi over 6. Okay, so that means that this angle right here will be pi over 6. Now, what are we integrating here? So in spherical coordinates, what we know, let me just delete some of the stuff. So we know that x squared plus y squared plus z squared equals rho squared. So when you take the square root, that's just going to give you rho. So that'll be here. And then you multiply that by something called Jacobian for spherical coordinates, which is rho squared sine phi. Okay, so that's what you're integrating. So let's see if we can integrate that. So this integral is splittable, which we can just split into 0 to 2 pi. There is no theta, so that's just going to be d theta. Then 0 to pi over 6 of sine phi. And then multiply that by 0 to 2 of rho cubed d rho. Okay, so the first integral is easy. That's just 2 pi. This guy is sine phi is negative cosine phi, so we integrate from 0 to pi over 6. And then this guy is just 1/4 rho to the 4th, and substitute 0 to 2. Okay, so let's see. So cosine pi over 6 is square root of 3 over 2. Cosine of 0 is 1, so we're subtracting actually negative 1 here, and then this will become 2 to the 4th is 16 over 4, so that's 4. So looks like I'm gonna get, this is gonna be a plus 1 minus square root of 3 over 2, and the whole thing is multiplied by 4. So I think this is gonna be 8 pi 1 minus square root of 3 over 2.